So I thought I'd do some a few of these problems and show you how I use this table that I made available, how I encourage students to do it. So these came from a different textbook, which you've seen just like it in the Lippmann textbook. So how do you do this how do you evaluate these trig functions without a calculator or without using that unit circle? So I see for number 25, I'm seeing an angle of 120 degrees. So I know that's about an angle of 120 degrees, and I know that the reference angle is right there. So because it's over in quadrant 2, I'm going to take that angle away from 180, and that leaves me a 60-degree reference angle. Now they're asking me to find the cosine of 120 degrees. So I see that my reference angle is 60. So I come over here to my table, and this is all based on the special right triangles that you learned back in geometry or algebra or one of those courses. So sine, I'm looking for cosine of 60. So cosine 60 is 1/2. So I know that the numeric answer is 1/2, but then I got to ask myself, is it positive or negative? Well, over here in quadrant 2, only the sine is positive because the y values are positive. That tells me the cosine is going to be negative. So this is a negative 1/2. You could certainly verify that on your calculator. How about something like number 29 with a sine of 13 pi over 6? So I had a student, the first couple of times I taught pre-calculus, she was having a hard time finding the reference angles when somebody gives them to you in radians, when they give them to you in radians. And she came up with, if it's in terms like, so if I got to evaluate 13 pi over 6, I know the reference angle will be pi over 6. Why does that work? Well, I know that this is 2 pi. I also know that it's 12 pi over 6. So if I go 1/6 more, 1/6 of pi more, I'm right there. And sure enough, there's my reference angle, pi over 6. So and that worked. It works all the time. So I know that I'm going to deal with pi over 6. I'm looking for sine of pi over 6. So pi over 6, of course, same as 30, which we don't really have to worry about. And the sine of that is 1/2. So I know the numeric answer for that is 1/2. So remember, I'm looking for the sine of this. So that's 1/2. And in quadrant 1 here, all the trig ratios are positive. So the answer is positive 1/2. Okay. How about the cosine of 23 pi over 6? Well, let's see, 23 pi over 6. There is 12 pi over 6. And if I went on one more full rotation, that would be 24 pi over 6. So I'm landing right there in quadrant 4. We use that student's trick. We know that reference angle is pi over 6. So now I'm looking for the cosine. So the cosine of pi over 6 is √3 over 2. And down here in quadrant 3, or quadrant 4, I mean, the cosine and secant, which you don't know about yet, is positive. So that means the answer is this positive 3 pi over 2. Okay, how about sine of 11 pi over 3? Well, 11 pi over 3 here. Let me clean this up a little bit. Let's see, how do I do image, select, let me get a fancy free form here so I can delete all of this. Okay, so 11 pi, what am I doing? 11 pi over 3. So 11 pi over 3. Well, here is, let's think about this. I know that's 2 pi. And if I want to rename 2 pi in terms of 3, that's going to be 6 pi over 3. Well, 11 pi over 3 will be an additional 5 pi over 3 here. So again, this is down here in quadrant 4. The reference angle of pi over 3, remember that, using that student trick, this reference angle is pi over 3. So if I go, I'm looking for sine. What's the sine of pi over 3? Well, that's √3 over 2. 3 over 2. So I know the numeric answer is √3 over 2. But down here in quadrant 3, only the cosine is positive. So that means the sine will be negative. That's negative √3 over 2. And that's how you can evaluate these. And this works for these other trig ratios that you've got to study, at least this year, this semester. Okay. Okay, so I encourage you to grab a copy of that poster that I have. It's I think it's useful, and it certainly keeps us from having to rely on the unit circle, which works. My calculus students this year for their AP, their high school students, are going to do the AP test, and I let them. They didn't want to learn this, and they wanted to just use a unit circle, and I said, fine, that's fine, but, and today we had the discussion, yesterday when I had the discussion, because, well, can we have the unit circle in on the AP test? And I said, no, you can't. You kind of got to memorize these reference angles. So they've got 2 months still before that test. So almost 2 months. So it's not fatal, but they gulped a little bit. So I hope this helps you do these kind of questions.